All right, good evening, everybody. Welcome to our special Facebook Live event called A Guided Tour of the New Solar System. My name is Mike Murray. I'm the astronomer and manager of the Delta College Planetarium in Bay City, Michigan. And joining me is our staffer, Brian Kennedy, who's going to be helping to keep an eye on the chat. Because if you have questions as we're going along, and we hope that you do, you can type them into the chat window, and Brian will do his best to answer your questions for you as we're going through. Really, the purpose of this talk is to kind of look at some of the unique features of not just the planets, but other elements in the solar system. And that's why we call it the new solar system. Of course, it's not really new in that it's a completely new solar system, but there are so many new discoveries that have been made with spacecraft that we want to show you some of the new things about it. So we're going to go ahead and get started. First of all, we need to define our term solar system, because we hear these terms, intermixed: solar system, galaxy, universe. They seem to get interchanged a lot, and sometimes it's hard to know which is which. So let's start by taking a look at our galaxy. And this is the Milky Way. And what I want us to do is to find our solar system. We're going to fly into the Milky Way galaxy. In fact, we're going to fly deeply into it. As you probably know, there are millions and billions of stars in our galaxy, but we're looking for just one particular star. Of course, it's a star that's very special to us. Now, you probably noticed it's not at the center. We're flying out into one of the spiral arms, about 2/3 of the way out from the center, and we're going faster than the speed of light, something that's kind of fun to be able to do in our animations. So we see many stars flying by. And here we're going to see a small yellowish white star slowly zooming up in the middle. And this, of course, is our star, the sun. In fact, let's take an even closer look. What is a star anyway? It's a huge ball of hot gases, mostly hydrogen, thermonuclear fusion going on in its core. That's what creates the heat and light that warms the Earth. And even though it's made of gas, it's the biggest, heaviest thing in the solar system, as wide as 100 Earths stacked end to end. And that means its gravity holds everything in orbit around it. And that's what we mean by a solar system. It is just one star, in this case, our sun, our star, that's holding many different kinds of objects in orbit around it. And of course, we tend to think of the planets as the primary part of the solar system, but there are actually many parts to the solar system, as you probably noticed. There are different belts of objects, small meteoroids that float in between, orbit in between the planets, and comets that come flying in from way out at the edges of the solar system. So we're going to take a tour of some of these different objects with a special eye on what's new, maybe some things you haven't heard about the planets and asteroids and such. So let's start with the planets. Mercury, of course, is the first planet from the sun, and it is now considered the smallest planet. At first glance, it may remind you of the moon, but that all changed once we got spacecraft to Mercury. The first spacecraft that went there discovered that it does look a lot like the moon. Craters piled on top of craters, even huge impact basins, like these rings you see marking a huge asteroid impact. But it didn't take long before we found some things that were not like the moon. In fact, look at this cliff. Mercury is covered with them. These cliffs can be huge, and the longest of them is 400 miles long. They probably formed when the whole planet cooled and shrank several miles, because Mercury has an unusually large iron core. And so when it shrank, it cracked and broke up into these cliffs. Think of an apple that's dried up. It's kind of that appearance. And some of these cliffs can reach 8,000 feet high. No other body in the solar system has so many huge scarps like this. Something missing on Mercury, of course, is air, no atmosphere, which means that there's no way for Mercury to even out its temperature. And so while it is the closest planet to the sun, it can bake to 800 degrees on the daytime side. But as soon as the sun sets, the heat radiates away into space and the temperatures drop to 300 degrees below zero. Now, here's something that was a surprise. The latest spacecraft, called Messenger, did actually find frozen water on Mercury. Up here on the North Pole, there are some craters that are deep enough that they are permanently shadowed. The sun never reaches down into the bottoms of those craters, and the instruments were able to detect frozen water here on Mercury's North Pole. Now we're looking at the second planet from the sun. Venus is the most brilliant planet in the night sky, as seen from Earth, brighter than any average star. And if you look at Venus through a telescope, it looks like this, very bright and white. Well, that's because Venus is completely covered in clouds. They reflect the sunlight really well to make it look bright in our sky. Now, we've known Venus has been completely enveloped in these clouds. In fact, we used to argue what lay beneath those clouds. It wasn't until more recently we were able to measure with using spacecraft the composition of the atmosphere. It's not like the Earth's. It's almost entirely carbon dioxide with acid rains that don't even reach the ground. It wasn't until we put a spacecraft in orbit around Venus in the 1990s called Magellan, it used synthetic aperture radar in order to map the surface, and we found volcanoes, cracks, canyons, lava flows. Turned out to be an incredibly tortured surface. We have landed some unmanned spacecraft on the surface of Venus. We found that it's incredibly intense. The temperature is even hotter than Mercury, 900 degrees at its surface, and a crushing pressure 90 times more than on the surface of the Earth. That'd be like being deep in the ocean. So even a spacesuit wouldn't help you there. But we do have other spacecraft that have gone into orbit and measured some of these properties. We found that more recently that some of the volcanoes are still active. In late 2020, there was an announcement of the discovery of phosphine in Venus's atmosphere, a substance that usually exists from biological processes. It started all the rage about whether there could be microscopic life in its atmosphere, but the results are still being studied by other scientists. That's the way science works. We need to throw it out into the community, get peer reviewed, have other evidence gathered, hopefully from other instruments. And we'll see if maybe that is really the only way phosphine can end up in Venus's atmosphere, or maybe there's other processes. All right, let's move ahead to the next planet. I think you all know what that one is. Yes, the third rock from the sun. No, not the television series. But we do continue to make discoveries all the time about our own planet. We do study our planet a lot, especially from space, in order to get a better idea of the sensitive ecosystem that we're working with. And when we study other planets, it tells us even more about our own world. One of the things we like to say is that the Earth is in the Goldilocks zone, which means it's not too hot, not too cold, but just right. And just right for what, you might ask? Liquid water. Water is what, of course, has transformed our planet into a life-giving world. It's the one substance we know of, at least in our case, that is necessary for life to develop and grow. Earth, of course, has something that Mercury and Venus did not, and that is a moon, a natural satellite, if you will, meaning it's not a man-made satellite. It was formed naturally during the formation of the planets, probably from a collision of a Mars-sized object with the Earth early in its history. It's been a long time since we've been to the moon with astronauts. These are the Apollo astronauts walking on the moon 50 years ago. Soon we'll be going back because there is so much more we can do there. A lot about the moon we don't know. The 6 manned missions that landed were good for reconnaissance, and discoveries continue to be made from unmanned spacecraft, like the detection of water ice. Remember how water ice was discovered at the North Pole of Mercury? Well, we've discovered water ice in the permanently shadowed craters of both the north and south poles of the moon. One of the main goals of NASA's new Artemis program will be to set up a small scientific outpost on the south pole of the moon, where frozen water exists, again in those permanently shadowed craters. What they'd like to be able to do, of course, is to harvest that ice for water, which can be separated into hydrogen and oxygen for many uses, including breathable air and rocket fuel. So in order to set up a base, we're going to have to find ways of gathering resources from the moon itself. Well, of course, the 4th planet, the last of the terrestrial planets or rocky planets, is Mars. And Mars, as you probably well know, has fascinated people for millennia because it's the only planet whose surface could be clearly seen from Earth through a telescope. The dark blotches, clouds, and changing ice caps have made some people think there was life on Mars. And that, of course, led to all kinds of science fiction stories and movies about Martians. And we still make them today. We're still fascinated as to whether life ever did exist on Mars. In the 1970s, we were able to get landers on the surface to successfully touch down and scoop up soil to sniff its composition. And of course, we were able to finally determine what the red color is from. There's a lot of iron in the soil, and water still exists in the ground as ice, and that has made the soil kind of rusty. Mars is only half the size of Earth, but it is a world of gigantic features, partly because its gravity is not so strong or not as strong as the Earth's. For example, we've got the Valles Marineris, the Mariner Valley, a canyon as long as the United States is wide. The tallest, largest volcano in the solar system, Olympus Mons, stretches almost 3 times higher than Mount Everest. Mars has massive polar ice caps that grow and fade with the Martian seasons. And while a lot of it is water ice, there is also a lot of dry ice, frozen carbon dioxide, especially on the south pole of Mars. Mars has an atmosphere, but it's incredibly thin, only 1% the pressure of Earth's atmosphere. That's like being at 100,000 feet in the Earth's atmosphere. But it's still enough that dust storms can kick up at certain seasons, and they can even engulf the entire planet. And yet Mars is still the planet that's most like the Earth, the one we most want to send astronauts to. Someday we'll have a base there so that we can learn more about what's happened to Mars. It's gone through some intense climate change in its history. And then, I think you all probably hopefully have heard, just recently, the latest rover, Perseverance, touched down on the surface of Mars to begin yet another chapter of exploration on the surface. Here's a view of that landing from cameras mounted on the spacecraft. The first time we've ever been able to do that. You see the tether system there. Once it touched the surface, the cradle would fly away and leave the rover on the surface. And yes, celebration abounded. So we're still, and there are other spacecraft, including rovers. The Curiosity rover is still operating, which landed in 2012. And this is the first panorama from Perseverance's camera that shows the wall over here in the distance of Jezero crater. It's going to be heading off into that direction in the coming months because this is where there's strong evidence of a flow of water, a floodplain like a delta. And it's estimated about 3.5 billion years ago, this area was covered with water, and large areas here were shorelines. So this is going to be the track that they're hoping to take the Perseverance rover on over the next few months. And its mission is designed to last 2 years, but like Curiosity, hopefully it will last much, much longer. Asteroids have been in the news too, where NASA just made an historic touch-and-go landing on the asteroid Bennu to scoop up soil and bring the samples back to Earth. The largest sample, the largest amount of asteroid material that's ever been gathered. The return capsule will be landing in the Utah desert in 2023, so we're eagerly looking forward to that. Well, beyond the inner planets and the asteroid belt, we finally get to the beginning of the gas giants, and of course the largest planet, Jupiter. Jupiter is, we call it a gas giant because it's all clouds and gas. It does get thicker and thicker, of course, even liquid metallic hydrogen it's called as you get deep down. And you see that it does rotate very quickly, much faster than the Earth rotates. Jupiter is large enough it would take 11 Earths stacked side by side in order to match its width. It's the biggest, heaviest planet in the solar system, more massive than all the other planets combined. Its most obvious feature is the great red spot, much like a giant hurricane, but large enough to swallow 2 planet Earths. And with no solid ground underneath, this storm has been observed for over 350 years. It does seem to change its size, its shape, and even its color, but it's still there. There's an active mission at Jupiter right now. It's called the Juno Orbiter. It's been in orbit there for several years, and it's the first spacecraft ever to go into a polar orbit around Jupiter. It's giving us the first ever views of the North and South poles. And the turbulent swirls of clouds, as you see here, is just as much art as it is science. There's just been some amazing features of turbulence in Jupiter's atmosphere. And Juno is still there and will continue to operate for at least another year. Jupiter has 79 known moons, but these 4 are by far the largest, the ones that we hear the most about. But it turns out each is its own special, unique world. As you can see with Io, it's an incredibly active world, active geologically, because Io is in this gravitational tug of war between Jupiter and its other moons, which gives it all of that activity. In fact, there are many volcanoes. It's constantly recoating its surface. This one you see here, this volcano with lots of sulfur coming out, has been seen to shoot material up as much as 90 miles above the surface. A close-up of Europa, the second of Jupiter's main moons, has a thick icy crust with lots of cracks, and it's very likely there is an ocean of liquid water underneath. And those stresses and pulls on Europa is what cracks the surface. But there's also heat underneath, which is helping to add to that instability and cracking where fresh water seeps into the cracks and refreezes. There's actually more water, more liquid water underneath the crust of Europa than there is in all the oceans of the Earth. Someday we would love to put an underwater explorer in that ocean to look for signs of life. A new mission, I should say, called Europa Clipper is scheduled to launch in 2024, which will make a much closer reconnaissance of the moon from orbit around Jupiter. But maybe someday we'll be able to actually find a way to get down into that ocean. I mentioned that the moons of Jupiter are very large, and in fact, the largest is called Ganymede. And not only is it the largest moon of Jupiter, it's the largest moon in the solar system, even larger than the planet Mercury. And here's the moon for comparison. Callisto orbits over 1 million miles from Jupiter, and that allows it to keep one of the oldest faces in the solar system. It's not subject to as nearly the kinds of stressing that its inner moons have. But Callisto does have unusual features of its own, including these spires of ice, which jut up over 300 feet high. Well, next, we have to go twice as far away from the sun as Jupiter in order to get to the next planet. You see, it's good to remember the planets are not evenly spaced like you tend to see in a lot of diagrams. Each planet is almost twice as far away from the sun as the planet before it. Saturn is the second largest planet, another gas giant. These are views from the Cassini spacecraft, which orbited Saturn for 13 years, and that gave us some new angles and perspectives that you could never see from Earth, including this backside view, where Saturn is eclipsing the sun. Saturn has more than 1,000 separate ringlets. They look like strands or grooves on a record. And thanks to the Cassini orbiter, it allowed us to see what was actually within those rings. Turns out they're not solid at all. They're made of chunks of ice and dust and ice-covered rock orbiting Saturn like 1 billion tiny little moons. Most of them are actually quite small. One of the reasons that we think Saturn's rings are so bright and so reflective is because they were created more recently. They probably formed when 2 of Saturn's moons collided and broke apart into all those tiny pieces, eventually spreading out around Saturn in that disk. Saturn has 82 known moons, most of which are tiny, but these here are some of the largest. And notice again the features. Each one, again, has its own unique look, and the Cassini spacecraft helped us to understand why some of these have unique looks. Like Iapetus looks like this side of the moon is covered in snow, and in fact, around on the other side, it's as dark as charcoal. And then there's Titan, the second largest moon in the solar system, and the only moon in the solar system to have a thick atmosphere. This is a composite of images taken from the Cassini space probe, and you can see that atmosphere. We can peer through and see some of the lakes of liquid methane. Yeah, it does have liquid and snow and ice, but it's not water, it's mostly methane. The atmosphere is mostly nitrogen, even about 2.5 times thicker than the Earth's atmosphere, but you got to remember, this is like a prehistoric atmosphere. It's about 290 degrees below zero there. One of my favorite moons at Saturn was Enceladus, a very tiny world. And before spacecraft got there, we just assumed that they would all be very cold, frozen, dead worlds, dead geologically. but we were surprised. You see these stripes, they call them the tiger stripes, and some of them are very thick, and they look like they have some fresh ice around it. That's because when we looked at those cracks from the side, we found that they were active. Eruptions of water and ice were bursting out of the cracks. Now, again, there's probably some gravitational stresses that Saturn is putting on the moon, but also there is enough heat inside Enceladus to have yet another liquid ocean, maybe a very salty ocean. And when it breaks through those cracks, you get these ice geysers. The next two planets are huge with lots of gases too, and they do look a lot alike, about the same size as each other. They have a lot of hydrogen and helium in their atmospheres, like Jupiter and Saturn, but they also have methane in their atmospheres, which is what gives them their green and blue colors. It absorbs the red light and reflects blue and green back out into space. Uranus was the first planet to be discovered using a telescope by Sir William Herschel in 1781, and this is about the best view we could ever get from Earth because it's so far away, more than twice as far from the sun as Saturn. All that changed though in 1986 when our first and still only spacecraft to Uranus made a flyby. Its atmosphere doesn't have the stripes and bands like Jupiter and Saturn, but we did get a better view of its rings, which are really, they look bright in this artist's impression, but they're actually as dark as charcoal. Very old. Uranus has moons too, not as many as Jupiter or Saturn, but we did find quite a few. This one is a really fascinating moon because look at its jumbled surface. Looks like it's been cracked and stretched and split. I kind of think of it as a jigsaw puzzle that was knocked apart and came back together with the wrong pieces in the wrong places. Now look down here to the lower left. You're looking at the tallest cliffs in the solar system, over 6 miles high. Again, a result of that fracture and collision. An artist's impression gives you an idea of what it might be like to go cliff jumping on Miranda. With its low gravity, because Miranda's so small, it would take you over 12 minutes of free fall to reach the bottom. That'd be fun. Of course, you can't use a parachute, no air, so you better have some kind of a jetpack to slow you down. Neptune is only a little bit smaller than Uranus. It does actually have some storms, like the great dark spot that appeared in the Voyager pictures in 1989, but that dark spot disappeared and others reformed. So unlike Jupiter's red spot, these spots do seem to come and go. And by the way, the white clouds here, those are not water clouds like on Earth. Those are frozen ammonia ice crystals in its atmosphere. Neptune also has some rings, but they're even thinner and darker than Uranus's. Again, an indication that they probably were formed much, much longer in the ancient past of the solar system. Some of them look like they're clumpy as well, almost like arcs. Remember the ice geysers we talked about on Saturn's moon Enceladus? Well, Neptune has a moon kind of like that. Triton has ice volcanoes that can spew ice up to 5 miles high. So again, even though we're getting so far out to the edge of the solar system, it's amazing how active some of these moons still are. Well, this would be the end of what we consider the major planets of the solar system, but they're definitely not the last objects. Of course, you probably remember for the longest time we had 9 planets. Pluto. And of course, the question always comes up, what happened? Why is Pluto not considered a planet anymore? It is still a real planet. It didn't get demoted. It just got reclassified because there are many things that we discovered about Pluto that have changed it, changed our impression of it, changed our view. First of all, look at its orbit. It's incredibly elliptical, and it's also tilted, not in the same plane as the other planets. When Pluto was first discovered in 1930, it was originally thought to be much, much bigger because our telescopes weren't really good enough to be able to estimate sizes very, very well. But as we got better at measuring Pluto, like when it passed in front of another star, and of course, as telescopes got better, like the Hubble Space Telescope, Pluto kept getting smaller and smaller, and the estimates eventually made Pluto even smaller than our own moon. We did discover some moons around Pluto, but it's still an incredibly tiny object. We never had a good close-up view of Pluto until 2015, and that was when the New Horizons spacecraft finally got there, and we saw this. The dark parts are rough terrain, in many cases much older, while the light areas are smooth. And that actually gives us some hints that there are changes on the surface of Pluto. Because look, there's no craters, no mountains. It's as though a lot of them have been erased. So even Pluto, at 400 degrees below zero, at the edge of the solar system, or the edge of the planetary area, still has some active geology. Taking some the imagery from the New Horizons spacecraft, we can simulate what a flyover of Pluto would be like. You can see there's a cryovolcano. Some of those mountains are actually water ice, and up to 11,000 feet high. They can stay intact because ice at that low temperature is as hard as rock. And look at the plains. It looks like they're divided up into plates. This is frozen nitrogen, and they float around on a warmer, slushy surface underneath, kind of like icebergs. So there is some warmth in the interior of Pluto. It could be from the radioactive decay of other elements deep inside, kind of like what happens on the Earth and other planets. So Pluto is still an incredibly fascinating world. We like to say that it's still, I guess you could kind of think of it as a different class of planet. You know, we have little tiny building blocks of planets, tiny little planetesimals, we call them, and then they grow to be protoplanets and then dwarf planets, which you could think of as just small planets, and then the major planets. Notice here, though, one of the reasons that we also found that Pluto is a dwarf planet is because we're finding many others. They're in this region called the Kuiper Belt, and that's where there are tens of thousands of smaller icy bodies left over from the formation of the planets. And in fact, Pluto is not the only dwarf planet. Let me give you a quick little tour with artists' drawings of what we think some of the other dwarf planets out there look like that have been discovered. So we are discovering new dwarf planets all the time, and many of them are out there in the Kuiper Belt. Some of them are just as large, if not larger, than Pluto. Speaking of the New Horizons spacecraft, almost 4 years after it encountered Pluto, it was designed to fly by a smaller Kuiper Belt object. And this is an actual photograph taken by New Horizons of the Kuiper Belt object called Arrokoth. And this actually was a wonderful confirmation of how we think planets form. Remember, we talked about them being small bodies, planetesimals, and these bodies gently stick to each other and grow. And you can see where it looks like here, two chunks touched and fused together. And this does help reveal how the bodies of the solar system grew. So is there anything out there past the Kuiper Belt? An area that is still held by the gravity of the sun? In fact, there is. And you can get a sense of scale here. There's the Kuiper Belt. And if you can see right in the middle, there's this little yellow oval. That is the orbit of Pluto. So the sun's influence stretches far beyond Pluto. And the particles of ice left over from the formation of the solar system get smaller and smaller into this huge spherical cloud called the Oort cloud. And you're looking again at very small particles. They might range anywhere from a little tiny fleck of dust or ice up to maybe 10 or 20, 30 miles across. But this is all still a lot that was left over in the cloud that formed the solar system. Now, one of the ways that we know that it's there is because occasionally one of these little chunks gets nudged out of its orbit and the gravity of the sun pulls it down in very, very close. And when the ice of that body gets close to the sun, it vaporizes and it sports a tail, and that's when we call it a comet. So comets, in pictures, they kind of look like meteors streaking across the sky, but they're not moving, not like a meteor anyway. They will seem to hang in the sky for days or even weeks. They will slowly change their position among the stars from night to night, but that's because they're out there in space moving around the sun. We've actually been able to bring some spacecraft close to comets. The Rosetta spacecraft actually went into orbit around this comet, Churyumov-Gerasimenko, which is a mouthful, so a lot of people just call it Comet 67P for short, its catalog number. The Rosetta spacecraft made some amazing discoveries about the conditions of the early solar system before the Earth was born, including the detection of organic compounds. Well, this brings us to the question about other solar systems. Remember, each star that you look at up in the night sky could have a family of planets of its own. In other words, you could be looking at thousands upon thousands of solar systems when you look at the night sky of stars. Well, spacecraft we've had up in space looking for planets that sometimes cut across the face of their parent star. They can cause the star's light to dim. We have several techniques for detecting planets orbiting other suns, what we call exoplanets. And there are now at least 4,000 planets that have been confirmed orbiting other stars in our Milky Way galaxy. So that kind of begs the question, are there very many out there that are like the Earth? Those are exceptionally hard to detect because they're so small, but we are finding some. And the question will become, if we do find Earth-like planets, what are the chances we could find life on those other worlds? Well, that's one of the reasons we're putting larger and larger space telescopes. Hopefully when the James Webb Space Telescope goes out into space, I think it's in another year or two, it will be able to refine some of our measurements of those exoplanets, maybe even getting spectra of the atmospheres of the planets and seeing what kind of conditions might be there, whether it's good enough for life. So we've just given you a quick tour of our solar system and some of the new things that we're learning about it. And what's great about astronomy and planetary astronomy is when we get a chance to make discoveries, it helps to add even more to our knowledge of the solar system. And it's exciting for us to be able to rewrite textbooks every so often. Science is not a collection or a body of facts, it's a process which we continually use to correct what we know or improve what we know, get a clearer picture of what is out there in space. So I want to thank everybody for joining us tonight. I hope you were able to get some of your questions answered. And we will continue to run some more special Facebook Live events. Be sure to tune into our website, delta.edu/planet. We also have a YouTube channel where we take this recording and post it on our YouTube channel. So just search Delta College Planetarium in YouTube, and you'll find a lot of the previous videos we've done, including a special series about the constellations. All right, so thank you all very much for joining us tonight, and hope you have a good night.